Post-it notes have been historically used to provide written reminders or tag different objects with additional information. What if sticky notes had computational capability, so everyday surfaces could be used as interfaces for the Internet of Things, responding to touch, swipes, or speech? We present Mars, a nano-powered, battery-free, simple wireless interface for human interactions. Each Mars tag is tuned to a unique frequency, allowing them to communicate on their individual channels. The Mars tag can be split into 3 parts: communication, sensing, and power harvesting. The communication system is an ultra-low power LC oscillator tuned to a unique frequency that modulates the antenna impedance to embed sensor information. Our LC oscillator is a type of resonant oscillator that uses zero-threshold MOSFET to amplify oscillations created by capacitors and an inductor. An isolating capacitor removes any DC bias from the output signal and feeds into a JFET that translates voltage changes from our signal to impedance changes in the antenna. Many types of analog sensors could be easily integrated into the Mars system by modulating the oscillator frequency. Inductive sensors could be placed in conjunction with L1 to modulate frequency, while capacitive sensors in conjunction with C1 or C2 to do the same. Finally, voltage-based sensors can be placed by C1 or C2 along with a varactor to translate voltage changes to capacitive ones. The low startup voltage and current of our oscillator enables simple power harvester setups with no power management. In fact, a single resistor is used to match the harvester power supply to the requirements of the circuit. Power harvesters include DC sources like photodiodes, TEGs, etc., or in the future, AC sources like RF with some added power management. A plain carrier wave that then strikes the antenna is backscattered, modulated by the antenna impedance. This is received by an RF receiver and demodulated to extract sensor information. Mars consumes power in the nanowatt range, much smaller than other backscattering technologies. This enables sensing of human interaction with many forms of power harvesting, no maintenance, simple circuitry, and thin form factor, like a post-it note. Mars stickers offer a diverse set of applications and interactions. Leveraging a thin paper microphone connected to Mars, we can enable audio or speech communication. The Mars audio tags can be embedded in a conference brochure and used as an extended microphone for central audio control, allowing the audience to ask questions to the presenter.
What are the power requirements of your prototype?
They can also be used for extending the hearing range of smart home devices to particular areas or appliances. For example, a Mars tag sticker on the refrigerator could allow a user to communicate with a faraway Alexa and update their shopping list.
Alexa, add eggs to my shopping list.
Alexa, add eggs to my shopping list.
I've added eggs to your shopping list.
Mars tags can also detect multiple discrete touch points. Powered by 2 photodiodes and leveraging inductance-based touch sensing, we create game controllers using Mars tags, with 2 buttons to play the classic game of Pong. We can also show the communication of unique IDs using capacitive sensing and Mars tags powered by photodiodes. For example, a waiterless restaurant can equip its menus with unique IDs to distinguish orders. Swipe-based direction control using capacitive sensing is also possible with a Mars tag. For example, we can command a light dimmer with our tag to change its brightness. In the future, Mars stickers open the possibility for building maintenance-free interfaces embedded on everyday surfaces and objects, which support natural like touch, swipe, and talk input.